can a machine learn to understand the world just by watching it? The same way a baby does? It definitely sounds like something out of science fiction, but a new paper from researchers at Meta suggests it might actually be science fact. And honestly, the answer could change everything we think we know about intelligence.
So, here's one of the really weird things about artificial intelligence right now. We have these models that are so powerful they can ace medical exams, write incredibly complex code, and create art that is just breathtaking. And yet they seem to be missing something completely, totally fundamental.
For all their genius, they just don't have that basic, gut-level understanding of the physical world that even an infant has. They don't get that an object can't just vanish into thin air, or that a pyramid flying around shouldn't just magically morph into a cube. It's this big, glaring, common sense gap.
And this isn't a new issue. It's so well known it even has a name, Moravec's paradox. The idea is pretty simple. For an AI, the stuff that we humans find really hard, like say advanced calculus or formal logic, that's easy for them. But the stuff we find totally effortless, like catching a ball or just knowing a glass will break if you drop it, that stuff is unbelievably hard for an AI to grasp.
Okay, so this gets us to the first big question here, which is just trying to understand this whole common sense problem with AI. Because before you can even dream of solving it, you have to figure out how to measure it. I mean, how do you even start to build a machine that can get past this paradox and get a real intuitive feel for the world?
So, first things first, how in the world do you test for something as fuzzy as common sense in a machine? It's not like you can just ask it. You've got to find a way to see if it really understands the basic rules of reality.
And the answer, which is just brilliant, comes from developmental psychology. It turns out the best way to test the machine's intuition is to treat it like a baby.
So if we're going to test an AI like a baby, what does that actually look like? Well, the researchers didn't have to invent something new. They turned to a classic method, one that's been used for decades to peek inside the mind of an infant and figure out what it expects to happen in the world.
It's called the violation of expectation paradigm, and the idea is actually super simple. You show a subject, in this case an AI, two different scenarios. One of them follows the laws of physics, like a ball rolling behind a wall and then coming out the other side. The other video looks almost exactly the same, but it breaks those laws. The ball rolls behind the wall and then it just disappears.
Now, human babies, they'll stare way longer at the impossible thing happening. That's their way of telling us they're surprised, that their expectation was violated. So the researchers applied that exact same logic to the AI. They showed a possible video, then an impossible one, and they measure which one creates a bigger huh moment for the machine, a bigger prediction error. That's its surprise.
And what's really interesting here is that other attempts to solve this have totally failed. You had models that tried to predict the future by literally painting every single pixel. You had giant language models that tried to reason about physics just using words, and both of them were basically just guessing on these tests. They couldn't tell the difference between what's real and what's impossible.
All right, so trying to paint the future pixel by pixel didn't work. Trying to talk your way through it didn't work. The Meta researchers knew they needed a whole new approach. So they built a model that was designed not just to see the world, but to imagine it.
The model that's at the center of all this is called VJPA. Now that stands for a big, long, complicated name, Video Joint Embedding Predictive Architecture. But what it does is way simpler and cooler than its name sounds.
So during training, they just showed the AI millions of videos from the internet. But here's the twist. They masked out big chunks of the video, just hid them from the model.
And this is the absolutely crucial point. Unlike those older models, VGPA's job is not to guess the exact color of every single missing pixel. That's just super inefficient and gets lost in all the tiny details.
Instead, its whole job is to predict a high-level abstract idea of what's going on in that hidden part. Think of it like this. It's not trying to guess the exact shade of green on a leaf. It's trying to guess the concept of a leaf rustling in the wind. It's an imaginer, not a painter. And by doing that over and over and over, it slowly builds an internal model of how the world actually works.
So the researchers let VJPA go to town on millions of videos, just letting it imagine the missing pieces again and again. And then it was the moment of truth. They put it up against those same baby tests. And this is where we get to the really surprising results.
So the big question, right? After all that training, did this AI actually develop something that looks like common sense? Was it surprised when the laws of physics were broken?
The answer was a huge yes. I mean, just look at the data. VJPA, that's the purple bar over there on the left, it didn't just do a little bit better.
It absolutely crushed the other models. The ones that predict pixels, even massive language models like Gemini 1.5 Pro, were barely better than flipping a coin. But VJPA, it spotted the impossible event almost every time.
Just how well did it do? Well, on a key test, VJPA hit an incredible 98% accuracy. 98%! And here's the wildest part. It did this zero shot. That just means it was never, ever explicitly trained to pass this specific test. Its deep understanding of physics just kind of happened, naturally, from watching all those videos. It just learned.
And this wasn't some fluke. The model really showed it understood the same core physics concepts that we learn as infants. Things like object permanence, knowing that an object still exists even when you can't see it. It understood shape constancy and even basic ideas about support and gravity.
So yeah, the results are really impressive, but what this means for the future, that's even bigger. This is the part that changes everything. Because this research isn't just about building a smarter AI, it actually challenges a really fundamental idea about how intelligence, even our own intelligence, actually works.
See, for decades, one of the leading theories in science has been the core knowledge idea, that humans and animals are just born with certain concepts hardwired into our brains. Like, we don't learn that objects continue to exist, we're just born knowing it. This research kind of walks up to that idea and says, maybe not.
Because what VJPA is showing us is that this core knowledge might not need to be hardwired at all. It might just be an emergent property. It suggests that if you have a powerful enough learning system and you just give it enough raw visual data, it can figure out the fundamental rules of the world all on its own. It's a huge idea. Common sense doesn't have to be programmed. It can be learned.
And that leaves us with one last kind of mind-blowing question. If an AI can learn the fundamental laws of intuitive physics just by passively watching videos of the world, what else is it going to learn next?